Receivers. The receiver must pick up the weak radio signals, select the right signal from the thousands of different transmitters located all over the world, amplify it to a suitable level, extract the audio or data picture from the modulated waveform, and then present it to us in a suitable form. Simple receiver. The block diagram of a receiver is shown in figure 5.1. Tuner and RF amplifier, demodulator or detector, audio amplifier. This is the speaker and this is the antenna. Block diagram of a simple receiver, 5.1. The radio signal is picked up by the antenna and converted into electrical signals which are passed along the feeder to the input of the receiver. Tune circuits in the receiver RF amplifier allow through signals in the desired frequency band and reject other signals. The wanted radio signal is selected by tuning the receiver to the correct frequency. The wanted signal is too weak to use directly, so the RF amplifier amplifies the signal in a transistor circuit. Tuning and amplification are covered in the intermediate course. The output from the tuning and RF amplifier stage is a single modulated signal strong enough to be demodulated in the demodulator. For amplitude modulation, the process has historically been called detection, a name that remains with us today. Demodulation is the opposite of modulation. The demodulator recovers the original audio or data signal used to modulate the carrier in the transmitter. The carrier is no longer required. The output from the demodulator is the wanted audio or data signal. Usually the signal is too weak and requires further audio amplification that is also carried out by a transistor circuit. The audio amplifier ensures the signal from the demodulator is powerful enough to drive headphones or loudspeaker. There may also be an output at a constant level for feeding to a data device such as the sound card in a computer that allows data, text or pictures to be received as well as voice. Type of demodulator. The type of demodulator detector used must be suitable for the method of modulation being used at the transmitter, AM, FM, SSB, upper or lower sideband. You must ensure that your receiver is correctly set for the mode being transmitted. Data signals sent as audio tones also need to be correct mode, FM, USB or LSB, as well as the correct data demodulator. Software defined radio, SDR, which are very common now. Many of the functions inside the receiver can now be carried out in software. The analog signal is sampled and digitized in an analog to digital converter, ADC. The front panel of the receiver need not look any different from an analog receiver or can be a plain box linked to a PC with an on-screen display with mouse and keyboard control. Early SDR receivers digitized the audio from the demodulator to provide improved filtering and suppress unwanted, interfering tones and noises. Advances in technology now allow entire bands to be digitized and all the signals to be separated out into individual frequency components in frequency order by mathematical software processes. This allows a visual panoramic display of the band like the ICOM 705 or the ICOM 7300. The wanted signal can be selected by mouse or keyboard. That signal is then digitally filtered and demodulated. A digital to analog converter can then present the user with audio, pictures or data depending on what was sent at the transmitter. The software processing can now remove unwanted interfering signals, annoying tones, much of the background radio noise, and generally clean up the signal. Similarly, if it was a data signal that was sent, then it too is decoded and output as data, like D-star. New modulation methods, especially for new data systems, can be handled simply by updating the software in much the same way as updating applications in a computer, tablet or mobile phone. Figure 5.2 shows a simplified block diagram of a software-defined receiver. Block diagram of a software-defined radio receiver. A to D, digital processor. D to A, or analog to digital, digital processor. Digital to analog, audio amp, speaker, antenna here. Software-defined radio, SDR. Figure 5.3 shows a software-defined transmitter. The microphone signal is digitized and filtered to remove frequencies below 300 Hz and above 3 kHz. A carrier is generated in software and digitally modulated with the audio. It is then converted to an analog signal, filtered to remove any remaining unwanted signals, and amplified for transmission in much the same way as an ordinary analog transmitter. Analog to data, digital processor, digital to analog, power amplifier, antenna, and that's the microphone. Block diagram of a software-defined radio transmitter. Thanks for watching. If you like my channel, please subscribe. 7-3, all the best. Catch you on air.